Hi, let us do a quick revisions for the course Reinforced Concrete Design 2 as a preparations for you before your final examinations. We have several questions here covering different topics within the course. You can try out these examples and do a quick self-assessment to know whether you are well prepared enough before your examinations. Bear in mind that the question here may not be able to cover every single aspect of the topics. I try to incorporate as many aspects as possible. At least it is good enough for you to do a quick revisions and probably help you to clear out certain doubts. Without further ado, let us get started. Question 1 is about the design of column. A typical final exam questions will ask you to first analyze the load before asking you to design the column. In order to analyze the load, you must be able to read the technical drawings. The question here shows you a structural key plan. It is stated that the structure is braced against the lateral load. This gives you an idea. When you need to design the column, you will assume that the column is braced. It is stated that the key plan is the same throughout the entire building. By looking at the details given here, you know that this is a double-story building. You have ground floor and the first floor. In terms of the floor key plan, you will have roof floor, first floor, and the ground floor. It is stated that all floors will have the same structural key plan, which is this one. Now let us spend some time to know the structure. Look at the grid lines here. In comparison to the grid line here, the elevations of the structures, it seems that it is viewing from this side. Grid line 1, 1, 2, 2, 3, 3, and 4, 4. You will have to be very careful with the grid lines given here. Sometimes the elevations may give you the view from the other side. If the view is coming from the other side, you will see the grid number here. It will be A, B, C, and D. Next, you may refer to the dimensions here. These are the beams, the slabs, and the columns. All beams have the size of 200 x 450. All slabs have the thickness of 150. And all columns have the size of 200 x 200. All numbers here carries the units of Eng-aim unless otherwise stated. Therefore, you know that all numbers here are in the millimeters unit. Based on the symbols here, you know that these slabs are one-way slab, whereas this slab are two-way slab. This is about the structural key plan. From the elevations, you will see the story height 4 meters, and it is indicated to you this will be the columns to be designed. Now let us look at the loading. There are GK and QK. GK represent the permanent actions, whereas QK represent the variable actions. The ground floor and the first floor have the same GK and QK, which are 1.0 and 2.0 respectively. As for the roof floor, the GK and QK, it will be half of the ground floor and the first floor. The notes given here seems that the GK is inclusive of the weight of the beam, slab, brick walls, and the columns. That means the values given here, it will be the summations of all GKs. You do not need to calculate separately for the weight of the beam, slab, brick walls, and columns. Next, let us look at the specifications. The concrete strength is 30 Newton per mm square, concrete cover 30 mm, steel grade 500, main reinforcement bar 12 mm, and the length it will be 8 mm. Let us look at the questions. We have quite a series of the questions here. Normally, you will not expect this many sub-questions in the typical final examinations. Normally, typical final examinations will consolidate the questions into 1 to 3 sub-questions. The sub-questions being listed here will serve as the guidance to you, step by step solving the final exam questions. As for the questions in the final exam, normally there won't be step-to-step guidance. Now let us first look at the question A. Refers to frame B1 to 4. We are asked to determine the size of the beam, the column, and also the story height. Refers to the structural key plate. Frame B1 to 4 is this frame. Now you know this frame, it will be referring to frame B1 to 4. The beam size is given here, 200 mm times 450 mm. The column size, it will be 200 mm times 200 mm. As for the story height, it will be 4 meters. That gives you the solutions for the beam size, column size, and the story height. Next questions is asking you to determine the slab adjacent to frame B1 to 4, whether they are one-way slab or two-way slab. In fact, this has already been implied in the structural key plate. Since you are referring to this frame, the adjacent slab, it will be these slabs. The symbol shows here it is a one-way slab. In order to confirm this, you will need to get the Ly per Lx ratio. When the Ly per Lx ratio is more than 2.0, then the slab, it will be one-way slab. Otherwise, the slab, it will be two-way slab. Let us first look at this slab. You can call this slab as AB/1 to 2, as given in the name here, AB/1 to 2. Based on the structural key plate, the longer span, which is 5.6 meters, it will be the Ly. As for the shorter span, 2 meters, it will be the Lx. Get the Ly divided by Lx. You get the ratio 2.8, which is more than 2.0. Therefore, you know that it is a one-way slab. You will do the same for the other slabs, and it will all end up to be more than 2.0. That means all the slab adjacent to this frame, it will be the one-way slab. Next, you are asked to design the UDL load. There are maximum UDL load and minimum UDL load. Why do you need to calculate the maximum and minimum UDL load? This is because later you're going to calculate the critical loads acting onto the moment, which you will require the maximum UDL loads and the minimum UDL loads to generate the critical moment. Now, how do you determine the maximum UDL load? First, maximum load will have both GK and QK present. And when you are talking about the design loads for the column, we are talking about the axial loads and the moment. These kinds of loads, it will be considered under the ultimate limit state. Therefore, you will require the factor of safety 1.35 and 1.5 for GK and QK respectively. As for the minimum load, you will assume that no variable actions is present. The GK will always be present. As long as the structures is in service, there will be GK. Therefore, the minimum load, it will be 1.35 GK. Now let us calculate the loads acting onto the beams. By referring to the structural key plan, the loads shall be distributed from the adjacent slab onto the beams, such as something like this. The calculations for the one-way slab is simple. You will assume that the loads is being split into half. Half of the loads being distributed to the beam here, whereas another half will go here. As for the slab here, same process, split into half. Half of the loads will go here, whereas another half will go here. For one-way slab, you will assume that the beams here carry no load. The calculation step is shown here. In fact, you don't need to refer to British Standard Act 110, as the table 3.15 of the British Standard Act 110 is meant for the two-way slab. The Ly per Lx ratio, the maximum it will be 2.0, which in your case here, your Ly per Lx ratio is more than 2.0. Therefore, the table cannot be used. Anyway, the equation here can be used as the basis for you to do the calculations. Since you are talking about half of the slab here, what you are actually doing is having the Lx multiply half of the length times the load, which is the GK and QK. This shall convert the area load into the UDL acting onto the beams here. There will be one UDL coming from this slab, another UDL coming from this slab. Same goes to here and here, also here and here. Since we need to deal with the factor of safety, we're going to need the GK and QK first. That's why we need to calculate the GK and QK separately. And then we'll calculate for the ground floor, first floor, and the roof floor. Half length times the Lx times the GK and QK, which is 1.0 and 2.0 respectively. This is referring to this span, 2.0. As for the slab here, that's Ls, it will be 2.5. You're going to do the same, half length times the Lx, which is now 2.5, times GK and QK, 1.0 and 2.0. Since the ground floor and the first floor have the same unit load, therefore the calculations will be the same. As for the roof floor, the GK and QK, it will be half of those in the first floor and the ground floor. With that, you get the GK and QKs from different slabs at different floors. Next, you will need to get the summations of the GK and QK. The total GK, it would be due to the 1 plus 2.5. It gives you a total of 2.25. As for the total QK, it would be due to the 2 plus 2.5. It gives you 4.5. You do the same for the first floor and then for the roof. Now that you have calculated the total GK and QK, bear in mind that these GKs are inclusive of the weight of the beam, slab, brick walls and the columns. You don't have to calculate them separately. Now in the case that the beam, slab, brick wall and the columns are not inclusive in the GK given, then you will have to calculate them to be added up with the total GK later. Having the GK and QK calculated, now you may compute the maximum UDL with the factor of safety 1.35 plus 1.5 GK/QK and the maximum UDL, which only constitute the GK 1.35. The UDLs acting on the ground floor and the first floor per unit length is given here. Whereas for the roof floor, it is this. As for the minimum UDL, it is equals to 3.04 and 1.52.